Happy Thursday, last day. Hey everybody. Anybody stay at the Hilton last night? I was expecting no, because there was no power last night, so we heard people maybe running a little bit late, but about 1 o'clock, everything started beeping, and then, at least for some of us, it beeped all night long, which were the smoke detectors, kind of on battery backup. And I was laying in bed thinking one thing, like, how am I gonna walk down 14 flights of stairs? So it came back on, so all good. Many of you have seen me in my IEEE capacity. I do have a day job. I work at Exelon, where I've been for some 36 years. I lead the transmission team there. And anybody that knows anything about transmission utilities knows it's super busy, so a ton going on. I have a great panel today, and we are going to talk about the obstacles, the challenges we need to overcome to enable the clean energy transition. So we'll start a little bit about framing it up. We'll talk about what we think those problems are. And I'm sure you just don't want to hear about the problems, right? We'll transition then into what we think some of the solutions are, what we need to do to overcome these hurdles. I'd start by asking you to be my panelist for what will be the first question as I introduce our panelists, but what do you think are the biggest challenges? And I'm going to limit our panelists to 3, and one of them already said he can't do it in under 3, but what do you think are the 3 biggest challenges that we face as an industry? So we'll work through those shortly, okay? So I'm going to introduce each panelist. I'm going to just do a brief bio. You can see more, I think, on the apps or on the web page. I'll ask them to feel free to add a little bit more if they'd like about what they do, and then we'll start with their 3 top challenges. And we'll go this way. We'll go left to right, okay? So, to my left here, Duke Austin, CEO of Quanta Services. And I think it's appropriate, Duke, to thank you for being the biggest sponsor for IEEE. You guys are great supporters and really appreciate that. So thank you.
Happy to do it.
So Duke, I just said he's the CEO. Quanta has grown to be a Fortune 300 company with over $17 billion in revenue and more than 50,000 employees. We have about 14,000 here. So triple that, all work for Duke around the country, the world. So big company. If I remember right, I think I heard you were a college football player too, so I had to get that in there.
A little bit, yeah.
So Duke, a little about yourself and what you think are the 3 biggest challenges.
Yeah, so 4 generations in the business. I came from Kraft, so been around it a long time. And when I see it, I think our biggest challenges as an industry, it's really policy. The policy from federal government at state level and the misunderstanding of what it takes to get infrastructure built. I see it daily. When you roll it back, it's really your customer and cost and how do you pay for it. So that really gets in the way in my mind. How do you pay for it, the policies that are there. And it's the greatest time in the business. It's the funnest time in this business. Like I've not, 4 generations of it, never seen anything like this where it's just daily something changes. Well, I think it's fun anyway. I mean, I'm not sitting in your seat, but again, I do think we as an industry, if we collaborate and we think about it and we start building this together, there's so much there to do. But that policy and politics and how it gets involved here is something that needs to get figured out, is who pays, how quickly can we get load. Those kind of things need to get worked out. I'm extremely concerned that we're going to have blackouts somewhere. And so that's certainly on my mind daily. And what do we do about that? So in general, I do think we're right on the cusp of something that is probably, we'll all look back and go, we did that as a group. And we always get there. But who knows, like 50 gig shows up every 6 months, and where's it at? Like it's everywhere.
It is.
And you get yourself planned, and we're good planners at the transmission level, but you don't know what's showing up tomorrow, and we're not in a static environment, and we have to be very nimble here and work together. So that's kind of my take on it.
Thank you. Marcus McCarthy is Senior Vice President of Siemens Grid Software. He's responsible for the business here in the U.S. as well as Mexico. He's got more than 30 years experience building hardware, software, technology businesses. He too is a Texan. We're dominated by the Texans today. So Marcus, in your opinion, the 3 biggest challenges that lie ahead?
Thanks, Joe. I got to thank Duke for taking my first point. So in the interest of keeping it interesting, I'll move to something else. But it's to pick up on something that Duke said, and it's around reliability and the time frame within which we're trying to make these changes. It's retiring, generating capacity like we are without concrete backups is a real risk, is a real challenge to the industry, and we're trying to do it in a time frame that adds risk to that. I think also to do it economically. I looked at, at the way it's been done in Europe, and I see a kind of a 40 cents per kilowatt hour price in Europe right now. In Texas, we're at 11 at the moment. I don't think consumers in the US want to go to 40 cents per kilowatt hour. So again, it's a mix of doing it, trying to do it too quickly maybe. But the final one and the most important one in my book is probably leadership. I see a lot of leaders within utilities doing a terrific job, incrementally getting better in their business every day across the industry. But then I see some other leaders who look forward at what will be required to get where they want to go, and then try and figure out how to make the steps to get there. Those leaders are taking different decisions or have a different vision than the people who are incrementally making their way forward. I don't think incrementalism is going to get us where we need to go for the carbon footprint objectives that we're setting.
Thank you, Marcus. Mark Baranek is a Senior Vice President at ComEd in Chicago. I joke with Mark when I go through his resume, it's easier to tell everybody what he doesn't do at ComEd. He has engineering, he has project management, he's got contract management, he's got smart grid. So he's got kind of everything D and then a lot of the T interconnections.
Right.
And Mark, you win the Dinosaur Award. You're 35 plus years with the utility, so congrats.
Very true.
Your thoughts from the utility on the biggest challenges ahead?
Sure. And good morning, everybody. Really excited to be part of this panel. And self-disclosure, I'm the one that told Joe, there's no way that I can wrap up all the things that are going on into 3 challenges. But I'll try to do that. So at a high level, I'll call it integration, data, and affordability. Certainly common themes that we've heard throughout this conference and different sessions. But in integration, Duke, you mentioned policy. We've got some progressive policies in Illinois and certainly in many other states. And it's a matter of how do we integrate that policy into making it happen? And then we know what's coming. We know EVs are coming. We know DER is coming. We know electrification is coming. We don't know when, we don't know where. How to integrate that and be ready for it and to keep the reliability of the grid, that's a challenge. In terms of data, we can spend certainly a whole nother session on data, but I define it as 3 S's. It's the source of data. It's very different depending on where the data's coming from. We need more of it, so that means that there's challenges of getting sensors out there in order to get the data and do compilation with it and get really good information with it. Where do you store it? Who has control over it? And then the other S would be security of data. Cybersecurity is a huge challenge. It's a challenge for our engineers to really understand that we've got to work very, very closely with our IT and our security teams on when we're putting in these new devices, that we keep in mind that there's parties out there that are trying to attack us every day and to undermine the grid. And then the last one is affordability. I know that's a common theme, and we've heard that as well throughout this conference. But it's not only affordability of our customers that I think is a challenge. There's also an internal corporate challenge when it comes to affordability, in that we're trying to manage things that will drive reliability or keep reliability and resiliency, but at the same time manage the capital needed for the growth of data centers, interconnections, and there's an internal affordability challenge as well as the one that comes with customers.
You did it. You did it in 3. Very good.
Thank you. I had a lot of subparts there, though, Joe. So.
Okay, and last but not least, Andre Bagoso is a senior partner at Kearney. He is the North America utility lead, everybody seems to have 30 years experience, Andre too. What I found interesting in his bio is he, quote, attempts and yet fails to be a cool dad to his 3 kids. He enjoys reading, tennis, ice hockey, and thick sarcasm.
A little bit.
Very good. Andre.
So I will summarize everybody's points into three. So I think the first one that we need to be acknowledged is people. The smallest generation that is coming to market is coming now. There is a shortage. There's no way for you to slice and dice across the industry. There's competition from other industries to the power industry in order to do that. So talent, not only in the engineering side, but on the field side, is a big challenge to get things done. And get things done, especially on the time frame that people think it needs to get done. The second one, I'll summarize, the affordability in terms of capital. There's not infinite money out there. The numbers that people are quoting are multiple sizes of the US economy right now in the next 25 years of spend. If you just think about the sheer magnitude of that and what's the bill impact that that's going to create. And the last but not least, I think, is the path. There is no agreement on how we're going to get this done. There's no clear roadmap like that used to be in the past. And there's very different conflicting industries and interests in what you see going forward. And those are the three big challenges that the industry across service providers, across utilities, and policymakers that are going forward.
Thank you. And affordability obviously is what customers pay. A new one that I've experienced recently as we've been awarded billion-dollar transmission projects is just the capital needs of the utility. We're getting to a point now where we almost can't afford to pay for some of these projects. We bring in some debt, some equity, and we're starting to actually have to go out and seek investors and other partners. So it's a whole new world. Okay, Andre, I'm going to put you back on the spot here. So Andre's got a worldly view, and I asked him to help think for us about, or help explain to us how big this prize is. What are we talking about in terms of
I'll
dollars
start
and time,
thinking,
et cetera?
the size of the global economy is about $105 trillion. The number being quoted that over the next 25 years, we need to invest $3.5 trillion every year. That gives you almost a little over $80 trillion. So we're talking an investment of a period of 25 years, maybe a little less, of 80% of the current size of the world economy. We spent at the highest last year, 1.8 trillion. So we're already coming out on a deficit. In terms of the integration, what are we talking about here? So there's 2,500 gigawatts just in the interconnection queue as of December 2023. About 1,500 of generation, the large majority solar, followed by wind, followed by a bunch of other small stuff, and the rest of the 1,000 of storage. Yes, FERC is trying to get into this with Order 2023. This is in the US, but these are the types of magnitude that you're trying to do this. So accomplishing those things are humongous. And I'll go back to the point that one of my colleagues did here, affordability. There is a magical number in utilities which stands for 5% of disposable income. Crossing that will put you at crosshairs with the regulators faster than you can blink. And that's a big, big problem that the industry, everybody, and when I talk to the institutional investors or the equity analysts that cover the utilities, their biggest question is that's great that they're going to spend all this money, but can they really spend that money? Those are the major questions behind it. Do they have the people, or they're going to spend the money and get 50% of the bang because there's not enough suppliers of all different types of equipment, or there's not enough engineers to do this. So I think those are big challenges that we need to, and that's the magnitude of the effort that you need to go forward.
Well, that is staggering, staggering. Duke, can you do $3.5 trillion worth of work a year?
Oh yeah, no problem.
No problem. So to that end, labor, construction projects, a huge part of this. How are you and Quanta preparing for this onslaught of work?
Yeah, I mean, I think we've invested about, call it 9 years ago, and we built a training facility around craft, and it's something that we felt like we need to invest in, and it's our biggest resource for us. And how do we get people, young kids, in the business? It was to me, we let the business kind of get stagnant, and people really didn't want to come to the utility side of the business. I have three sons in the business, and they all went different directions. Now we did some things, and we actually bought Blattner, which was balance of plant solar wind. When we did that, like, it changed us, because now the young ones, they want to come in because they want to solve the problems of, you know, the world and some of the climate change and things like that. It's just different. So working on that and then we bought a college to go around that, because what was happening for us is we weren't understanding the youth, the new generation. Like, you could no longer go out and say, my father just said, you're going to go to work to eat. I mean, it was that simple. And, you know, I couldn't tell my kids that. They're going, no, I want to go over here. So really had to work on them, and I felt like we had to go way back to go forward. And so the company really invested early in, as kids in high schools and things like that, trying to do a really good job with, you know, the young ones. And people say, well, it's this kind. It's really not. If high school sport, if a kid plays a high school sport or has an after-school job and they go through a pre-apprentice program, they're like 90% likely to get through. Two things. And we study it, and that's what it is. And so you can take CAS tests, you can do all that stuff if you want to. I don't think it's necessary. And really think about the trade from a standpoint of what's necessary and how quickly can someone get through it if it's focused. And the brain, and, you know, when we bought the college, I learned a lot about academia. And you'd say, well, what the hell are you thinking about academia for? But in general, like, you have to really teach these young ones that are coming in to the business and make it something that they can really put their hands on. And so it's short burst training. We had been training people the same way for over 50 years, 60 years. My great-granddad had the same program that we were doing today. And so when I think about it, we as an industry got to change and really look at the youth and bring them in. We added 4,000 last year. So we're able to really ramp that if we need to. But you have to have journeymen to train craft. And it's a fallacy to think you can just throw up 1,000 people, especially in distribution systems. It doesn't work that way. You just can't throw 1,000 people out there. So we have to be systematic about it as a group and think about, you know, distribution planning, all those kind of things matter to us. So I think the plan matters, and how you get youth in the business, and I'll do a good job of that. And hey, this is great. I mean, I get up and say, I'm blessed to be here. I love this business, all I know. And like, it's something to me that means something. And for everybody in this room, you're going to leave a legacy right here. And having been down in Puerto Rico and seen a grid that like, when you shed load and that governor calls you, we can't do anything about it. Generation, we don't even control it. But they don't care. Your name's on that bill. And so I just think for us, we know that craft is something that we have to make sure that we're right on, because the industry is dependent a bit on us to, like, make sure that happens. And so I do take it to heart, and I do think we all have to continue, and we have to help too. Like, if we know things, inner cities, and be diverse and inclusive. We need everybody. Like, this is a simple thing. Like, it's not about like D&I or everything else. We need everybody. We want everybody. So as a group, you know, I think we're doing a good job, but look, it's staggering. And we all have to be cognizant of what we can do and all plan together.
And I read you bought a transformer company?
We did.
What are we thinking there?
Yeah. My board thought I was off the rocker. But, so we were pre-COVID, and I was thinking through it, the vertical supply chain, and we're not in the manufacturing business, to be honest. I think transformers for us, our clients and our customers, U.S.-based, were really pushing for us to think different. And internally, we do a lot of EPC, so I mean, we could backstop it with our internal usage. That said, I do believe like we had to invest to keep our people busy. I was worried it's so hard to train, it's so hard to get these people, and then all of a sudden, no offense to the manufacturers, I get it, but it's not there. And you go, okay, it's going to be here in 24 months, and all of a sudden it's 36 months. Well, like, try to put union labor out there and figure that out. Like, what are you going to do with that? So really try to get more efficient internally, and then as a byproduct, work with our customers on it. I've enjoyed it. I've learned a ton about transformers. I know how to hook them up. Inner workings were something different. But it's certainly a business that we like, and we think we can help make a difference here in the U.S. and do some unique things, and we're proud to have it.
Excellent, excellent. So Marcus, moving to manufacturing, assuming Duke gets the people, we're going to need materials. So I'd like you to comment a little on the material lead times. How are the supply chain constraints going in the U.S.? And what are the impacts of, you're a little bit in the software area, what are the impacts of digitalization and software?
So I took a look last night, and I compared with current lead times with Q1 22. And if you take a look at a distribution transformer, lead time is approximately 2 years. It was 4 months in Q1 22.
Wow.
A power transformer is 127 weeks last night. It was 78 weeks, Q1 22. A HV circuit breaker was 151 weeks last night. It was 74. And then the real killer, a large transformer, is currently 4 years. It was 1 year in Q1 22. Wow. So what Duke is saying about lead times is absolutely true. A lot of it is driven by the fragility of global supply chain at the end of the day. There's a lot of reasons written and talked about, but at the end of the day, the fragility of global supply chains is a fundamental effect. What we're doing is we're working hard to bring manufacturing onshore here. We spent $510 million last year alone. We're building a new plant in DFW, building a new train construction facility, $220 million in North Carolina, and expanding our plants in Grand Prairie in Texas, Pomona, California. So again, we're trying to bring it onshore to help with that. Is it a solution? Will it fix the problem in the near term? Probably not. We're seeing a lot of a collaboration with our customers. It's time to work together on it. To be honest, it's a real problem. It is a real problem. And so, look, bringing it onshore, trying to make it more available, less dependent on these global supply chains is one thing that we're doing. And on the other side, then, we believe the other part of the answer is around software, artificial intelligence, and that's really around planning, asset management, operations, activities that can impact life cycle and can impact how you prepare for this and maybe operate a little bit better. So just to give one example of something that we're doing in that area, and it speaks to the distribution transformer problem. We probably will need about 5 million distribution transformers in the U.S.
Wow.
In the next 5 to 6 years, right? So that's now when you think about that number, right? There's a good reason why Duke bought that business. That's what there is. He's looking forward a little bit, and he can see what's going to happen. But what's happening right now is that we're allowing people to connect EVs to the distribution network willy-nilly without any permitting and any understanding of the impact it's going to have on the network. And so we've developed software that can take AMI data. It can disaggregate the AMI data. It can understand EVs, PVs, batteries, and it can do that on a grid scale. So now you can take a look across your network, take a look at it to the distribution transformer level, take a look at it on your feeder all the way up to your substation. What is the impact going to be? Because without that data, the utility is operating blind, and they may be building a silent disease on their network because, we buy distribution transformers with a 40-year lifespan in mind, right? Mm-hmm. If Georgia Tech have done research, you continuously overload that transformer, don't let it cool down properly, 4 years is the lifespan you're going to get from it, right? So, and we run a lot of our networks to failure. So what happens when it fails? We send a truck out with another one, put it back up there, and that's not
right. We put it up today thinking it's going to be there 30, 40 years from now.
That's not the answer to this, right? So we got to get smarter with the data. And then we got to figure out, right, can we, if we have 3 EVs charging every evening at the same time on this distribution transformer, can we incentivize somebody to put a $500, $1,000 battery in here, right? And it's not just the cost of the transformer, which may be between $2,000 and $5,000. It's the supply chain impact as well, right? So it's more complicated. So can we get people to charge at different times? Can we? But without data, you don't know where to begin looking. So we see that as part of the solution here. It's a two-part answer.
Thank you. So Mark, you're kind of where the rubber meets the road is the utility. Some insight for the audience on what you're seeing with respect to all these new interconnection requests. How big are they? How much, how much is coming in?
Yeah, so Andre mentioned the 25 gigs in the interconnection queue, and I kind of feel like it's all ComEd, but I know that's not true. So ComEd is part of the PJM ISO, and we are certainly seeing a large queue of interconnections. And it's both wind, it's solar, and even though the state of Illinois has a goal by 2050 not to have any fossil fuel generation, we're still seeing combined cycle gas plants as well coming online. So it's quite robust in terms of the interconnections on the transmission side. Just recently, we had a project that kicked off that was going to support over 2,000 megawatts of both wind and solar in Illinois. ComEd is just a transmission distribution provider. We don't have generation, and so we're agnostic to all of the generation that's coming on, but it's a big queue. And when we talk about interconnections, I have to add the distribution interconnections. And we tend not to think of Illinois as the sunniest place on the planet, and that's true, but it's an incredibly robust market of solar coming in. Last year, we processed over 20,000 solar applications, and we're expecting it to grow again this year. Most of that is rooftop, but we're seeing a huge queue of community solar and commercial industrial type of solar between 2 to 5 megawatts. So we've got a few hundred of those types of projects of the 2 to 5 megawatt range, and then certainly we're expecting that the rooftop solar is going to exceed the 20,000 applications. And even though it's not necessarily interconnection, the other thing that we're seeing, and it's been talked about quite a bit, again, through this conference, Illinois is a pretty big draw for data centers as well. ComEd's peak load is somewhere around 23,000 megawatts, and it seems like every month we're hearing another 200 to 300 megawatt data center, asking to bring, to connect and come online. So. And we've got actively over 2,500 megawatts of data centers, and I think there's probably double that that's being considered. So quite a robust renewable market in Illinois.
Yeah.
And those are some of the challenges.
So it's not hard to find articles from a lot of people trying to interconnect new resources to the system, complaining that the utilities are the bottleneck, and I'm sure that makes you as happy as I do, right? It's frustrating.
It is.
So here's your chance. How would you reply to the utilities being the bottleneck?
My reply to you, Joe, is you got to read some other articles. And we need to write different articles because, certainly it's reality that to go ahead and interconnect these large projects, it's going to take a long time, particularly with building new transmission substations. Marcus had talked about the lead times that's reality. And so the utility's not the obstacle with that. I think we're an opportunity to help the developers to at least understand what obstacles are out there and work with us to ensure that we know what those are. And there's things that I think certainly we've been doing with our developers to at least help to expedite. And so how much risk do they want to take before full scopes are engineered and designed? There's ability to go ahead and do that and to get orders on long lead material items in early. Even through our own process, helping through with commitments and deposits of getting internal procedures approved to say, the customer's serious and we're going to move forward with this, helping that out. Some of the other things that I think also we're doing is trying to get our engineering teams to, in particular on these longer lead items, how do you standardize more of it so that if projects do move and timelines move or internal projects move, we've got the ability to move that equipment to different projects depending on what types of either delays or other challenges come up. So there's quite a bit that we can do. I don't, the utility's not the obstacle. There's obstacles out there, and frankly, we need to work with our customers to ensure that there's an understanding of that.
Yep, very good. I have a couple more questions, and then we're going to afford time if the audience has any questions, okay? So if you do, think those up, and we should have about 10 minutes for audience questions. So Andre, back to you. We heard as we work through policy being such a key issue. What are the biggest policy issues we need to tackle in the near future?
I think that permitting, everybody agree, should be number one on the list. Ability to get things built. There's a lot of things to be built, and we need people to build those. But permitting is number one. I think that it needs to be federal and permitting reform for us to be able to build the infrastructure that needs to be built in order for us to transition into the future to more. I also do believe that there is no future in the short term without natural gas. I think that needs to be said over and over. People don't understand how good at $2.50 natural gas actually really, really means. It allows for a lot of renewables, a lot of investments. Try to put natural gas at 8 and see how high the customer's bill go and how fast all those investments are going to be actually shut down by the regulator faster than you can blink. So I think that those are two interesting. I don't think we need to continue to bash natural gas the way the industry is doing or the federal government is doing, but it's a really, really important part of the transition. The time frame for a 2050 net zero is really aggressive, a lot of money, and the other part that we are not talking about is the change in interest rates. Higher interest rates actually make investments more expensive, for lack of a better word. So I think those are the things that we need to start thinking about and talking about in terms of how to build this going forward.
Thank you. As I sit in transmission, one of the conundrums we deal with is the areas that are congested or where we need to take equipment out of service, to reconductor, to add new towers. It's getting more and more difficult to take something out of service to build. So I wanted to ask Duke a little bit about the capabilities Quanta is enabling to work equipment live. I had a chance to go to your ranch, and they let the attendees grab live 345 kV, and I said no thank you, and I stepped back and let everybody do it, and I regret that I didn't do it, but you've got some really new capabilities. How much can you do? What voltage can you go up to? What can you or can't you do?
I mean, the voltage is unlimited, honestly. I think, it's different. It takes a different process, and I think the training that goes behind energized reconductoring, we've done a bunch. We're on 250 miles there in Texas now for LCRA. But in general, I think, yes, we have the capabilities. It's a different skill set. I always relate it back, like if you're a lineman, it's like being a brain surgeon when you're doing this. But the planning that goes into it and everything, I think it's safer than what you would think. Our record would say so in doing this. But in general, it's necessary, I think, to get the grid where you want it. You're going to have to do some things energized that you've never done before. You have to think a little different. We've got to plan a little better on how to, out at the facility, we have structures from everyone basically, and we're able to really pre-plan the work before you start. And I think that pre-plan of what kind of structure you're on, we're using helicopters. We just acquired Sherman Riley, and everyone said, why you acquire Sherman Riley? Well, I'm concerned with those pullers and our people and the safety. It's a 100-year-old company. We depend on them. My granddad depended on them. And so we have to think through where the industry is going, let's give Gretzky's quote, we got to skate where the puck's going. If you don't, then you're in trouble. And I think we, as an industry, everything I've heard, we got to think about what 5 years from now looks like. And I do think there's a lot of more modularization. There's a lot more energized reconductoring coming at us. And I sit in a public CEO role. I'll just say this so I can get it out there. Putting this build in a 90-day period is the worst thing we could possibly do as an industry. If we don't look at this in decades, then we are in trouble. Because the pressure of Wall Street on a 90-day term, it just doesn't work. And look, I sit and I get yelled at, whatever, but for me, just own it and move on, because it's much, much bigger than these 90-day windows. I get it. Look, you're under financial pressure. You're under all kinds of pressure from regulators, and you're under pressure from S&P and Moody's, and you name it. But the fact is, we're going to have to be nimble, and I think reconductoring along with this and trying to get ahead of things will certainly help us as we move forward.
Yeah, thank you, thank you. Okay, I think we have some SCE folks. Thank you for volunteering in the green shirts. They've got microphones, so if you raise your hand if you have a question, they'll find you. It's a little hard for us to see with the lights here. So just briefly your name and who you work for, and then your question.
All right, we've got a couple of questions, so I think you've got to pick the question.
We're going to let you. Yeah.
Hi, I'm Narayan Bhusal. I work at Oak Ridge National Lab. So we have been analyzing power outage data for US for last 6-7 years or so. And the power outage has been it has been increasing year by year, and it seems very scary when we look those data. We have been looking throughout the US. So what I see from that is, so with new technologies and then like an aging infrastructure, and then these increasing outages due to disaster. So what do you think is power grid in US is ready to handle all these changes? Are utilities investing enough to take those challenges for next decade or so? Because what I see is if we don't do those investment, we will be probably face similar challenges that Puerto Rico has been facing for the last decade or so. Thank you.
So it's a utility question, so I think
Take it away,
automatically, Joe, I'll go ahead and take that. So, yeah, that's, certainly part of the challenge, right, is are we ready to take that on? I certainly, can speak for ComEd in that it's just a challenge in terms of convincing some of our external stakeholders. Shameless plug, last year, ComEd won an award named as the most reliable utility in the country. And, we were very proud of that. But some of our external stakeholders feel, well, geez, if you're already that good, you really don't need to invest anymore because, you can just coast, right? And it goes to the question you're posing, which is, no, we need to continue to invest because we don't want to get behind one. But then secondly, exactly to your point, with all of these additional DER and different expectations that customers have, the distribution grid, from a legacy standpoint, was never two-way, right? And we got to get to a point where it's going to be two-way. And then one of the other investments that we are really pushing hard on is advanced communication for ComEd. So how do we connect all of those devices and be able to do things such as dynamic hosting capacity or automation to where it is a two-way power flow and the system can function very, very quickly. So the answer is we have plans on what investments that we need to make in order to continue with that reliability and resiliency. It's a question, again, of the affordability and making sure that we can get all of our stakeholders to agree that those benefits are worth the investments that we're looking for. Yeah.
Very good. Other questions?
Yeah, hi. My name is Bill Meehan. I'm with Esri, the GIS company. So as we look at the need for more and more transmission, you brought up the point of permitting as a really big issue. It just takes forever. What about the use of transportation highway right-of-ways or railroad right-of-ways to help with some of the location of transmission lines? The permitting for that would be a little bit simpler. Any thoughts on that?
I can take that one
Yep,
too.
yep.
Sure. So absolutely, you know, at least for ComEd, we already have many of our right-of-ways that parallel either railroad lines or tollways or interstates. So continuing to go ahead and build that out is absolutely an option. There's certainly challenges that come with that as well. You know, railroads have issues with induction, and you know, there's technical aspects that you need to think about. There's also costs if you're not on your own utility-owned right-of-way. But those are certainly, you know, to your point, you know, what else is contiguous out there in order to go from, you know, point A to point B for, you know, hundreds of miles? It's interstates, it's railroads, and you know, perhaps even gas lines. But we have a lot of gas lines that are also on our right-of-ways. But that's part of it. I'd say when it comes to permitting, you know, we've had some successes with new transmission. Certainly, as you get into more of the suburban or urban areas, underground transmission is about the only way that we will get permission. And, you know, obviously that's a very expensive play.
Yeah, yeah, and living in the transmission world, I would quickly add, you know, maybe we have it a little bit backwards because people come to us, I want to interconnect here, and then we look, you know, maybe there is a highway or somewhere that we can utilize, but, you know, they're telling us where they want to go. And if you go to the D system, we've done things like hosting capacity where we broadcast information to customers where they can interconnect, where EV stations might work. And I think one day with T, we need to broadcast that as well. We have right-of-ways. Can you build something out in this area? So I think inverting that would be helpful. Another question?
My name is Robin Podmore with Incremental Systems. So I've been involved in Smart Village, lighting up the world, and also building entrepreneurs, and also training grid operators. So we have a catch-22 right now that we can model the entire system, but everything's very proprietary. And we still have students testing on the IEEE 118 bus system. What can we do to really accelerate the whole process of getting people competent to run all the studies, and what can we do to, you know, why can't a lineman be trained to go into a power plant, take all the measurements, and go back home and do the modeling? The modeling is becoming a huge part of what we need to do, and like you're all saying, it's all about the workforce. But imagine right now if we couldn't get access to Google Earth and Google Maps. Literally, the models are just not available. We're in a totally fragmented industry, and you can be totally compliant at very, very low cost and do the checkoff. And so we train a lot of people on a hypothetical system. And so the idea is how do we really get the networking that's happening here with IEEE and really get the students involved to handle these issues and make everything really exciting like you're doing? And how do we really take this society and have a lot? How many linemen are in this room? Who's climbed poles?
Duke.
Yeah, give those guys a hand, okay? But there's not enough, all right? Okay, so I guess, yeah, how do we really do that cross-training and really get the boots on the ground people telling us what we should also be doing? Thank you.
Anybody want to take that one?
I mean, I'll just say from our standpoint, it can't be done at home. I mean, so you got to get people back to work. You know, and there's nothing. You can't take kids out of college and desktop it. They really need to go back to the basic and see how it works. And so I worry that we try to do this like you're saying on desktops. Yeah, okay, it'll give you some knowledge, but you've got to see it because it changes. The field, what you're doing when you hit the field and how you're doing things is so much different. And I think as an industry, we got to take the time with the younger generation to make sure that we're doing a good job of, I'm not saying you can't work from home, you probably just won't go up. There's jobs that do that, it's fine. But in general, I think in order to get where you want to go, you got to show kids how things work in the field and touching, and it just goes a long way as far as someone's character. My sons, I make them go to the field. I want them to spend time.
Yeah.
Feel it a little bit. So I think that helps the industry. And I'll say on technology, what I see, the car charger knows more than you do or a utility does about your system in many areas. I don't think that's good long term. And so we're going to have to figure that out, and whether it's data on the edge, however you want to do it. Certainly all the things, all the models, you put 2 degrees either way on it, try that one. Put 10 degrees on your system and plan, try that. So you got things coming at you where either temperatures are rising, we can't say it's not. So all these things are coming into play, and it changes every single model. And who's putting the number in? Is it going to be 112 in Texas for 30 days or 118 or 100? Because it matters. And I get shade peak, I got it. But like when you bring the peak way up and the bottom's coming up and peak gets higher, you got to figure these things out. And those temperatures, when you do your system planning, I'm speaking to what you know already, but it really, really moves the needle.
Yeah, thank you.
Can I add to that, Joe?
Please.
Yeah. One of the other things is getting, and going to the tech side, is getting a standard model operating. So not a different model for planning and a different model for operations and a different model for, so there's a lot of people working off of a lot of different models, and it would be good to see more standardization there. It'll give us more practical decision making. And then one of the other things, we're seeing a couple of things with modeling that are really important right now. First of all, the ability to use the cloud, to have a model on premise, and then use processing power in the cloud, 200 processors simultaneously, to solve something in minutes that used to run overnight right now. Doing that sort of thing can make the whole process of planning and simulation a lot faster, a lot more attractive to young people to use. A lot more usable by AI because the old method was too slow. One of the other big trends we're seeing is what we're calling co-simulation. So you have your power simulation model on your transmission side, and you have your model on your distribution side. Well, we're starting to see a need for being able to co-simulate. So simulate something here and see what the impact is here, and the other way around. So the models are talking to each other continuously. And then you can run contingency analysis really, really quickly across those and start to plan for what might happen. So there's a lot of sophistication coming into the tools to assist. It's a very good question, and it's a fundamental building block that we need to figure out.
Yeah, great question. Thank you. Thank you. Our panelists, real quickly, any technologies that excite you through our history? It's been one of the biggest enablers to move the grid forward. Anything excite you? Transmission-wise, technology-wise, anything?
We've got a lot.
You got a lot? Pick one.
So
Pick
yes, there's a lot of exciting things. I mentioned that we're also trying to build in our whole communications network, right, to tap into and to decrease latency of operations. But with that comes distribution, linear state estimators, phasor measurements. We're putting in weather stations across our territory. We're working with Argonne Labs in our backyard in terms of climate study to see, where else can we leverage, the future so that we can get ahead. So it's not only technology, but it's also different thought processes as to how to get in front. So a lot of exciting things. Duke, this is an exciting time.
Yes, sure is.
And we can truly make a huge difference.
I will say one thing, not to sound large language models, particularly that are very supportive of inductive logic will revolutionize engineering as we know. Basic engineering will be done by those models within less than a decade. And this is something that it will change the world. And high-level engineering will probably continue, but like those models do not underestimate their capability in terms of what we call inductive logic, which is like things that work in the past, work in the future. That's the basics of it. If you guys ever interested, there's the initial paper on that was written in 2013 by a bunch of Google engineers. It's more than available online, but the applicability and the power of computing on this. And not to sound a little more data centers, guys, that's a curveball for the industry. I'm not even going to joke about that. The lower projections, we're talking 88% of the load by 2030 will be data centers. A high-end projection is 30%. How do you even deal with that? So those are the technologies that I think are going to be really impactful coming in the very near future.
Thank you. All right, we're gonna close in 1 second. I'm gonna ask the panelists in just 30 seconds to each tell me why they have optimism that we're up to the challenge. But little housekeeping before that. We've got another panel that comes on immediately after us at 9. So once complete, we're all going to exit stage left there. The next group will get mic'd up. We'll step outside in the hallway if anybody wants to talk or has some follow-up questions, okay? All right, so Andre, we'll start with you and we'll work back way, but speed round, last comments. What gets you excited? Why are you optimistic we can do this?
I'm excited because every day is a new problem. Like the other day, my colleagues and I were talking about one of the suppliers. Should we vertically integrate on the copper market? I was like, wow, that's a new one for me in the utility industry. But it gives you an idea of what people are thinking about in what are the challenges. Because without processed coppers, guess what? There is no transformers. And things like that. And I'm very excited about the AI piece of the business. I've seen that change in the way I personally work every day, and I see the impact that it has on my clients and my colleagues, and it's something really exciting.
Mark?
Yeah, for me, I get excited because I see the new engineers, the new talent coming in, and I know that we may not have answers right now, but I'm optimistic that this generation will be able to do that. And when I was coming through early in my career, I wasn't as tuned with all of the different, I'll say, social and impacts that perhaps just the pure engineering types of solutions are. And I think I see a lot more of that. And we absolutely need to be folding that in. We can't leave customers, we can't leave communities, we can't leave different aspects of the population behind, and I think we're getting much more in tune with that, and whatever those solutions are from a technical or engineering perspective, they have to be dovetailed with all of those other issues, and I think we are much better primed for that in the future.
Thank you, Mark. Marcus?
I'm really excited by the fact that our industry is becoming one of the most important industries to society, to humanity.
Yes.
It always was, by the way, but it wasn't acknowledged like that right now. People know it. And I'm really excited by that. I'm excited by the work that the industry is doing in the U.S. The U.S. is the home of innovation, right? It's a natural part of the character of the U.S. And I can say that because I've come to live here. And I'm excited to see what the next 10 years brings. There's terrific people working in the industry. It's not run by sales and marketing or other theorists. It's run by engineers. I'm confident we'll solve this problem.
A lot of people like that run by engineers comment in here, I'm sure. All right, Duke, bat clean up here.
Yeah, no, when you look at what's in front of us and you think through it, and you're right, we're right in the middle of tech, and anything you can think of, people ask, who's the customer? It's somebody different every day. And I think it's the most unique time we've ever had onshoring. But as an industry, we always come together. We always get things done. It's always difficult. There's always challenges. And the fundamental philosophy is we have a duty to serve. And it's not only serve the customer, but it's ourselves. And when I think through, this is the greatest time you'll leave your legacy. And no matter what you think, when you go, it's not what you did, it's what you left behind. And so this is the greatest time for us to leave the right thing behind. And so I get to look back and say, what did we do in this generation to make it better for the next generation? So that's what excites me the most, and to see my kids and everyone else and the young ones coming through, it's the most exciting time we can have, and look forward to what we can all do together.
Yeah, very fitting way to end. So please join me in thanking our great panel today.